In this lesson, we will be talking about parallel lines and triangles. The objectives are to use parallel lines to prove a theorem about triangles and to find the measure of the angles of triangles. So the first theorem that we have is the triangle angle sum theorem. And we've already talked about this in our previous lessons. The sum of the measures of the interior angles of a triangle is 180 degrees. So in this particular triangle, we have the measure of angle A plus the measure of angle B plus the measure of angle C is going to equal 180 degrees. The next definition we have is for an exterior angle. The exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side. And we'll look at this in a diagram below. With the next definition is for remote interior angles. So for each exterior angle of a triangle that you have, the two non-adjacent interior angles are called its remote interior angles. We're going to use those definitions in the next theorem. But let's look at the diagram below. In this diagram, we have angle 1 is an exterior angle because it's formed by a side of the triangle and an extension of an adjacent side. So here's the side of the triangle, and here's an extension of an adjacent side. So that's what forms that exterior angle. Now the two remote interior angles are angle 2 and angle 3. They are remote interior angles for angle 1. We're talking about angle 1 as the exterior angle, and so the two remote interior angles for it are angles 2 and 3. So that leads into the next theorem, which is the triangle exterior angle theorem. The measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So in the diagram above, we have measure angle 1, which is the exterior angle, is going to equal the measure of angle 2 plus the measure of angle 3, the sum of the two remote interior angles for angle 1. So we'll apply these to the problems on the right. So let's go over to the right, look at problem 1. In problem 1, we're going to use the triangle angle sum theorem to find the values for x, y, and z in that figure below. So let's look at finding the value for x first. So we have two different triangles inside this larger triangle. So let's look at the one on the right first. So the sum of these interior angles of this triangle have to equal 180. So we have x plus 32 plus 46 is equal to 180. Well, 32 and 46 is 78, so we're going to subtract 78 from both sides. So if you take off 78, then subtract that from both sides, we're going to get that x is equal to 102. So now let's look at finding y. There's a couple of different ways that you can find y. Y is an exterior angle to that triangle that I've drawn in red. So since it is an exterior angle, that means that it's equal to the sum of its two remote interior angles. So y is equal to 32 plus 46, which is equal to 78. So that's one way to find y. The other way we could have found y is that x and y form a linear pair. So they're supplementary by the linear pair postulate. So we could have said that y is equal to 180 minus x, which would have been 180 minus 102, and would have still gotten us the 78 as well. So now let's look at finding z. So let's look at the triangle on the left. So in that triangle, we just found that y was 78. So we can use the triangle angle sum theorem again. The sum of the angles of that triangle have to be 180. So we have z plus 36 plus 78 has to equal 180. So let's see, 36 and 78 is 114. So subtract 114 from both sides, and z is equal to 66. Moving on to problem 2, we're going to use the triangle angle, that exterior angle theorem on those. So let's move down to that. In problem 2, there's two parts. The first question asks, what is the measure of angle 1? Angle 1 is an exterior angle because it's formed by a side of the triangle and an extension of another side of the triangle. So that means that the measure of angle 1 is going to equal the sum of its two remote interior angles, which are 46 and 41. So that means the measure of angle 1 is equal to 87. In the second one, in part B, what is the measure of angle 2? Once again, you have an exterior angle. The exterior angle is 119, and it is going to be equal to the sum of its two remote interior angles, which are measure of angle 2 and 53. So if you subtract 53 from both sides, measure of angle 2 is going to be 66 degrees. In the last problem, it asks what is the value of x. Once again, we have an exterior angle formed by a side of the triangle and an extension of another side. That's 110 degrees. So the exterior angle, 110, is going to be equal to the sum of its two remote interior angles, which are x and 60. So if you subtract the 60 from both sides, then x is equal to 50.